Okay, so for this problem, the trick to starting this problem is that when you are going to set up your factoring, you're going to have everything in the same trig function. So one of the identities you've probably learned at this point is that sine squared theta plus cosine squared theta equals 1. It's called the Pythagorean identity. And what I'm going to do is solve this for sine squared. So sine squared equals 1 minus cosine squared theta. And we're going to substitute that where we have our sine squared in the problem. So right now we have 1 plus cosine theta minus 2 times 1 minus cosine squared theta. And basically I'm taking this expression, substituting it for sine squared here, equals 0. The next step, we're going to distribute the 2, or the negative 2, and we're going to have 1 plus cosine theta minus 2 plus 2 cosine squared theta equals 0. And rewriting, combining like terms, we have 2 cosine squared theta plus cosine theta minus 1 equals 0. And what I usually do is set up a problem where I'm calling cosine x and kind of do this factoring work off to the side. So this equation is equivalent to 2x squared plus x minus 1 equals 0. And to factor anything where the first term a, or the first coefficient a, is not equal to 1, we need to multiply a times c, which is negative 2, and b, which is 1, and we're looking for two things that multiply to negative 2 and add to 1. And those two pieces are positive 2 and negative 1. So our middle term is really positive 2x and negative 1x. So I'm going to rewrite this as 2x squared plus 2x minus 1x minus 1 equals 0. We're going to factor by grouping. So we split the problem in the middle, in between the two terms, and then you're going to factor out a 2x. We're left with x plus 1. And in the second term, we've factored out a negative 1. We're left with x plus 1. So our factors are 2x minus 1, which are the outside terms, and x plus 1, which are the inner terms, equal to 0. So the next thing I'm going to do is solve these problems. So I have 2x minus 1 equals 0, 2x equals 1, x equals 1/2, or we have x equals negative 1. So looking at that, our x was actually cosine. So going back into the problem, we have that cosine theta equals 1/2, and cosine theta equals negative 1. So what we're going to do is look at the unit circle and figure out where these situations happen. So cosine theta being negative 1 is the easier situation. Cosine is positive 1 on the positive x-axis, and it is negative 1 on the negative x-axis. So this happens at 180 degrees. Or if you're using radians, it happens at theta equals pi. Alright, so cosine being 1/2. So cosine is the x-coordinate on the unit circle, and we are looking for an x-coordinate of 1/2. So this x-coordinate is square root of 3 over 2. This x-coordinate is square root of 2 over 2. This x-coordinate is 1/2. So we are looking at this angle right here. And that angle is actually 60 degrees. So it happens when theta is 60 degrees. It will also happen one other time. So looking at the quadrants, everything's positive here. Sine is positive in the second. Tangent's positive in the third. Cosine's positive in the fourth. And we're looking for a positive cosine. So I know it's going to be basically a mirror image here, where this reference angle is also 60 degrees. So we are taking 360 minus 60 to get that second angle, which is 300 degrees. So theta could also be 300 degrees. In radians, theta is going to be pi over 3, or 60 degrees times 5 is 300, so we have 5 times pi over 3, or 5 pi over 3. So there are 3 answers to this problem.